Alright, so today what we're going to be looking at is vectors, but this time with letters. Vectors with letters. So this is going to be like basically algebraic expressions of vectors as opposed to what we was using as well before with the column vectors, but we will be mixing the two. So the determinant expression for vectors represented as letters, and then we wanted to determine whether two vectors expressed as letters are scalar multiples of each other. So I want you all to take this down and then we'll go through it. And once we go through it, we will see if we understand the concept of vectors with letters. Alright, so this is what we're looking at here now. So this time we have OF represented by a letter A. So we're saying that O to F is considered to be A. Alright, so we are expressing that in terms of letters. A. Now OG, same thing, we're saying that O to G is represented by the letter B. So O to G represents B. Now here is telling us what A represents. So A represents -5 to 9, B represents 7 to 3, right? So this is a column vectors version of what OF is. So the same thing here, what we usually do. So O to F, it says that it's -5, 9, right? Because OF is the same as A. So it's like going 1, 2, 3, 4, 5. So that's the -5 part. Then we're going up 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're going 5 to the left and 9 up. So 5 to the left and 9 up. So that way we would have an understanding of what that is. But we are calling this whole move A. From O to F is known as A. Now likewise for OG. OG we are calling it B. So we are saying that B represents 7 moves to the right and 3 moves up. So O to G is 1, 2, 3, 4, 5, 6, 7. Then we go up 1, 2, 3. So 7 to the right, then 3 up. 1, 2, 3. Now, this wants us to represent it in terms of A and B. So O to F is actually represented by A. So O to F is actually A. So we could put here A. Does that make sense?
Yeah.
So what you think OG is? What is OG?
B.
Correct. OG is B. So FO now. So FO, very interesting. Remember last time we said that we have inverse vectors. So if OF is A, what is FO?
Minus A.
Excellent. Minus A. So if FO is minus A, what is GO?
Minus B.
Minus B. All right. Now let's look at FG. So usually we said to get from F to G, in this case, we're going F to O, then O to G, right? So I can say that FG is equal to F to O plus O to G. So F to O plus O to G. So F to O is minus A. And what is OG?
B.
So minus A plus B, because OG is B. So here is equal to minus A plus B. We could also write it the other way around, like B, then put minus A, so it looks like this. Either one would be correct. It's essentially the same thing. Okay, now GF. Now GF is literally gonna be GO plus OF, right? So GO plus OF, what is GO? Minus B. So minus B plus OF, which is A. And if you notice, see the B is minus here, but here is positive, and here the A is negative, and here is positive. Is the same concept like what we was doing before. We just changed the signs. Okay, does that make sense to everybody? All right, so I want you all to take this down. So take down this part here, and then take down 1 to 6, and we'll do 7, 8, 9, 10 together. All right, so I'll give you all time to write that down. So we know that FG is also represented by minus a plus b. Okay, so what we would do is, we know what a is, which is this. So what would end up happening is that f to g being minus a plus b, we could say minus open brackets, because we're going to put this here, minus 5, 9. Then we're going to add to that whatever b is. So b is 7, 3. Now, because this says minus 5, remember the negative and the negative. So this is like having negative 1 here. So negative 1 times negative 5 gives us positive 5. And then negative 9. And we're going to add to that the 7 and the 3. So 5 plus 7 is 12. Negative 9 plus 3 is negative 6. So then this here is my expression for f to g, 12, negative 6. And we could also test it out. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we go down 6, 1, 2, 3, 4, 5, 6. All right, so that's that one. Okay, so I want y'all to take this one down. So let's try number 8, ladies and gentlemen. Number 8. So number 8 says M is the midpoint of FG. So we want to put a little line here to help us visualize what that might be like. So I would say M being the midpoint would probably be like right here. All right, guys, that looks like the midpoint of FG.
Yeah.
Lovely. So they say to write FM as a column vector. So technically, FM is equal to what? What do you think FM is equal to? It is
8.
How you got that?
I went across from F and then go down to M.
Check it out though. I didn't expect you to get it right, because what I wanted to let y'all see is that FM is technically what? Half of FG, right? So it's half of FG. Now, what is FG? So FG, we already know what FG is. Look at right here. FG is this. So this is telling us we have to find half of this to find FM. So if you look at it, FM is therefore equal to half of FG. Now FG is 12, negative 6. So we're going to find half of 12. What's half of 12?
6.
6. And half of negative 6 is what?
Negative 3.
Negative 3. So this is 6, negative 3 as a column vector. Okay? 6, negative 3. Now, if I needed to do it as a expression here with A and B, I know I could use the same concept, because FM is equal to half of FG. I already know what FG is. What is FG in terms of letters?
Minus A plus B. Minus A.
Lovely. So all I need to do is put here half and whatever that is. So I'm going to put B minus A. Right? So half of B minus A. I could have put half of minus A plus B. And this is my expression for it if I was doing it in the form of letters. And right here is my expression for it in the form of a column vector, which is what we were looking at. Okay? So take this down, and then we'll go through 9 and 10 together. All right, so let's try MG now. So MG. So now I want to put that in terms of these letters here. Okay? So MG. What do you think MG would be? MG is what? If you look here, M to G is essentially the same thing. It's half of, what's it half of?
FG.
Lovely. So if I was to write this so you could see MG, yeah? MG is half of F to G. So I could put here half of FG. So M to G is equal to half, and FG is essentially what we had, B minus A. Okay, so my answer for that is MG is equal to half B minus A. So essentially what we did here, all we did is figured out that M to G is half of FG. Why did I use FG specifically? Because we already had an expression for FG. Okay, so Let's look at number 10 now. It says OM. Now, if I'm starting from O, who could tell me how I can get to M? Just if you was driving on a road, you want to get from O to M. How can you do it?
Go across one and then go up 6.
Okay, so that's the coordinate. Yes, you are correct. You could go across 1 and then go up 6. But now, let's pretend like the graph behind wasn't here and you driving on a road now. How? And you have to go from station to station. How can you get from O to M?
From O to G to M.
So O to G plus G to M, right? How else can you do it?
O to F to M.
O to F plus F to M. Kind of connecting back from what we did last time, right?
Yeah.
So we go O to F, F to M. Or we could go O to G, G to M. Now, let's try O to M first. So O to F, we already know what O to F is. What is O to F? A. So A plus FM. What is FM? Do we have anything that tells us what FM is?
Half of FG.
Lovely. Which is half of B minus A. Alright? So I could actually simplify this. So I could say A plus. Now with this here, I need to multiply this half to each of these. So half times B and half times minus A. Alright guys, this is just a tricky part of vectors when we start mixing letters in it, right? But half of B, we put that, and then we'll have minus half A. So I could group them together. So I'm going to have A minus half A plus half B. Now I have a question. This A is the same as saying 1A minus half A. So if you have 1A and you subtract half A, how much do you think you would have?
Half?
Correct. We'd have half A, and then we'll have plus half B. So essentially what we have here is that this is A, this is half B minus A. So when we work this out, you realize that A plus the half B, we have to group the like terms. So the minus half A and the A, we group them together, which is why we have this. So then now once we work this out together, we get half A plus half B. So even with this, I could prove to you that we would get the same thing that you said, 1, 6, right? So let's do it with this first. So OG. So O to G is B, and then now we have GM. So actually here we don't have GM, we have MG. So what we can do is change the sign. So we will have plus half, because remember it's the inverse. So if this is B minus A, half B minus A, GM surely would be half minus B plus positive A. Okay, because we just changed the signs, right? Just like here, FG was minus A plus B, and as you can see, GF is A minus B. So let's work this out now. So we have here now B and then half of minus B, so that would turn to half, which is positive in this case, times negative B would turn that to minus half B. Then positive half times positive A would give me positive half A. Now 1B minus half of a B would give us what?
Half of B.
Half B. Lovely. So then we have half B plus half A. Notice how two of these are the same. This and this. Alright, you see that? So I want you to take this down, and we could also prove that it works for, so for the coordinate part, we know that O to M is 1 to the right, and then 1, 2, 3, 4, 5, 6 up. So if we was to work this out, we should get that same answer. So take this down and I'll explain that. And then of course, I'll give you one to try. Alright, so just to show you, if we had to express this as a column vector, I'll take this half and just factorize it out. So I'll say half outside A plus B. This is the same thing as saying this, because this here is half, this here is half. So you can just factor it out and have A plus B. Now, if I substitute what A plus B is, I'll have negative 5, which represents the A, as well as a 9. And I'll add that to the 7, okay, plus the 3. So negative 5 plus 7 is 2. 9 plus 3 is 12. Half of 2 is 1. Half of 12 is 6. So then our answer here is 1, 6 for OM as well. Now if we was to walk out from OM, we would go 1 to the right, then 1, 2, 3, 4, 5, 6 up, which represents this. Okay, so I want y'all to take that down as well too, just for a little example, heads up. And then after, I'll give you one to look at so we could try it together. All right, time to try the next one. So, let's see what y'all get for the first 5. So let's see what y'all get for the first 5. So once you do it, send it to me. So the first part, OK is basically represented by C. Say that here is C. Then OJ is D. And KO, so K to O. So since O to K is C, that means KO must be minus C. And then if OJ is D, that means JO must be minus D. So KJ is K to O, because we're going from K to O, then O to J. So K to O, we know what that is, minus C. So minus C plus OJ. So OJ is D. So we could have minus C plus D or D minus C. Now for 6, they told us that they want us to express KJ as a column vector. So if we are expressing it as a column vector, what that means is we need to take that information we had there and use the coordinates or the column vector to get what we need. So 6. So KJ, we are saying minus C plus D. So all I need to do is replace the C with minus C and the D with 6, 4. So minus C. So I just need to put whatever C is, which is here, negative 8 and then 6. Okay, so this represents minus C. Plus D. So the D part is 6, 4. So minus 8 is going to turn to positive 8. And then minus 6 is going to just be minus 6. We're going to have here now 6 and 4. And we add those together. So then we will end up with 8 plus 4 is 14. Negative 6 plus 4 is negative 2. Alright, and that's our answer for number 6. Now, number 7, JK. So we want to express JK in the form with these letters. So all we need to do is change the signs. This is minus C, this is going to turn to positive C, and so forth. Okay, it's just the inverse. Signs change. So this turns to positive and that will turn to negative. But let's do it just the long way in case. So we could say J to O plus O to K, because we're going like this. J to O, so we're going the opposite direction of this D. So because this arrow is telling us that D goes this way from O to J, that must mean that J to O is minus D plus O to K. So O to K, we're going in the direction of the arrow. So O to K is C. Alright, so J to O is minus D because we're going against this arrow, against this instruction. And then we go O to K, which is in that direction. So minus D plus C. Alright, so it says 8. L is the midpoint of KJ. So let's say we had a line from here, KJ. We're saying we have a midpoint. So L is a midpoint. So we are saying write KL as a column vector. So we want to do K to L as a column vector. So we know what KJ is. KL, sorry, is half of KJ. So I'm still expressing it in the form of a column vector. So I know what KJ is. Look, we have KJ right here. This here is KJ. We have to do half of that, which is equal to half KJ, which is 14 minus 2. So half of that. So half of 14, 7. Half of negative 2, negative 1. So that right there would be our value for 8. Now, for number 9, we have LJ. So guys, LJ is the same half of KJ. So then that means LJ would be the same thing as half KJ. So LJ is half KJ, but we want it not as a column vector, but we want it in terms of C and D. So we know what KJ is. KJ is minus C plus D. So all we have to put is minus half of minus C plus D. And that's now the last one, 10. OL. So 10 is OL. So remember, we have 2 ways to go. We could go O to J, then J to L. But I already have KL, which is here, and I have O to K. So my journey could be O to K plus K to L. So with that in mind, I could say O to K, as you can see, going in the direction here is C. So then we got C plus K to L. So we go O to K and then K to L. So K to L, as we got from here, is half kj, right? So half of kj, what was kj? Kj was minus c plus d, right? So equal to c plus half of negative c. So you don't even need to put this here. I could just say half of negative c. So positive half times negative c will give me minus half c. And then positive half times positive d will give me half d. So then c take away half c is equal to a half c plus half d. Alright, not bad, right? Alright, so OA, we see that OA is equal to 3A. OB is equal to 2B. AO would be the opposite of this, so minus 3A. BO would be the opposite of this, minus 2B. AB is going to be from AO plus OB. So that will give us AO, negative 3A, plus OB, which is 2B. And then BA is going to be negative 2B plus OA, which is 3A. Alright, so that's for number 6. So 7 now. It says express AB as a column vector. If A is this and B is this, GE is the midpoint of AB. Right, AG as a column. Oh, so we still on this AB. So AB now is minus 3A plus 2B. So what I'm going to do is replace A. So it's going to be minus 3, open brackets. So the A is going to be this, minus 5, 9, plus 2 times B, which is 7, 3. So negative 3 times negative 5 is positive 15. Negative 3 times 9 is negative 27. And then 2 times 7 is 14. 2 times 3 is 6. So 15 plus 14 is 29. And negative 27 plus 6 is negative 21. And that's the answer for that one. Alright, so we have G being the midpoint of AB. So let's see, we had G here. So this is for the second question. So G is the midpoint of AB. So we already wrote that down. So now we need to write AG as a column vector. So A to G. So as you can see, AG is half of AB. And right here, we have AB. So AG is equal to half AB. So AG, as you can see, is half of AB. So we'll just say half here, open brackets, 29, negative 21. Okay, so I'll just express this as half. So 29 divided by 2, I could leave it as 29 over 2, and then over here is going to be negative 21 over 2. Alright, so 29 divided by 2 is 14.5 if you want to put it as decimal, and then negative 21 divided by 2 is negative 10.5. So that's our answer for number 8. So number 9, so remember we want to express it in the form of AB. So 9 is actually half of AB as well, because GB, so from G to B, because we're going in the direction A to B, GB is equal to half AB. So therefore GB must be equal to half whatever AB is. So we had AB right here, which is negative 3A plus 2B. So half of negative 3A plus 2B. And that's it. So number 10 now, we have OG. So OG. So O to A would give me that. O to A. So O to A plus A to G. Alright, so we know what OA is. OA is 3A plus AG. So AG is half of AB. So we already established that here. And half of AB would be half AB, negative 3A plus 2B. And from here we could try to simplify it. So this here is already the answer, but sometimes they ask us to simplify it. So if you have to simplify it, you could go 3A. So positive times negative is negative. So half of 3 is like 3 over 2. 3 divided by 2 is half, right? And then half of 2B would give me just B, because half of 2 is 1, so 1B. So now I have 3A take away 3.5A. I have 3A take away 3 over 2A. Alright, so if you was to put this in a calculator, all you have to do is say 3 take away 3 over 2, which would essentially give us 3 over 2A, and then the last part plus B, and that's our answer. You can see stuff like this on an exam when you have letters involved sometimes where they ask you to simplify the expressions. So that's something to look out for. But when you get it like the column vectors are usually nice questions, right? So if you don't have this, just take it down, and then after I'll give y'all a next one to try.